One of my favourite scientists is Henry Cavendish. Even though he was part of the rich dukes of Devonshire, that family, and incredibly rich, he went to Cambridge to study natural sciences, or natural philosophy as it's called. But he had a very curious condition in that he could hardly talk to anybody. So when it came to his Viva exam after 3 years of study, he fled Cambridge rather than sit in front of the examiners because he was petrified of them. But he was one of the most brilliant scientists of that 18th century.
Okay, great. So he is the only person, apparently, to have come up with an experiment to prove gravity, which I think is based on two objects of mass will be attracted to each other, and that's to prove gravity. But apparently, the only reason I looked into this is because I was having an argument with somebody online. They were trying to tell me gravity is just a known fact, where I was just saying it's not, and this is all they ever tell you. So I felt obliged to have a look into it, and apparently this experiment has never been replicated, just like all experiments that we've been given to prove one theory after another to prove the globe Earth. This is just another example of some outlandish story, groundbreaking experiment that revolutioned and just changed the world and backed up a theory. And yeah, so I was trying to find this experiment being replicated and demonstrated. So I think I found the video, so let's have a watch.
Towards the end of his life, he did a crucial experiment, which is represented by these lead balls. At the back of it, he had a big garden shed, which might seem like the size of my house. And in it, he had two lead balls, like this, suspended from the ceiling. Only this is not to scale. This is, lead balls. Now, the real problem is that he wanted to measure the attraction between two objects due to gravity. In other words, there's a gravitational attraction between you and me, or between me and this lead ball.
So gravity, which is a theory, and was only invented because they said that the Earth spins, and it's needed to explain why things don't go flying off the spinning Earth. And as far as I know, this is the only so-called experiment, like this chap's explaining, that gravity, according to them, is all objects of mass are pulling towards each other. And so this experiment is supposed to demonstrate that. So let's see.
So he had to be a long way away to look at the experiment, otherwise he'd interfere with it. So he had an aperture, a place where he looked through, and he put a telescope out there, and he stood outside in all weathers, and he was in his 60s doing this, staring through the window to take his measurements over a year. There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated.
Yeah, I don't think I need to say much else, do I? The technician got frustrated, so he sawed it apart because it doesn't work. Brilliant. So if you're having a debate with anybody about gravity, okay, and they try and throw this in your face, just send them to this video. Cavendish experiment, 60 symbols. This is such a good experiment that they can't even replicate it without taking a hacksaw to it.
And then right in the middle there's a bit of glass, there's a mirror which should be suspended from a torsion wire. So you'd set it up like this in his shed, and you put it like that, and this lead ball would attract that lead ball, and this lead ball would attract this one. And so it would be pushed a little bit this way and twist the wire, and that would be pushed a little bit that way, and the wire would twist, and as the wire twists, the mirror which is dangling in there, would twist a little bit, and light which comes in would be reflected off at a slightly different angle. And all he had to do was measure the angle. He then had to move it the other way round. Oh, he didn't move this bit. He moved the lead balls round so that you had an equal and opposite effect on the other side. So instead of having, you'd have that configuration. He had this is a very complicated technical thing for the time. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. 18th century we're talking about, and he put that way round, and then it was pushed the other way, and you could then see the displacement. Moreover, you could measure the period of oscillation of this, and from that get all the properties of the wire, the torsional constant. And that enabled him to measure big G, the gravitational constant, to an accuracy of 1%. And nobody improved on that for 100 years. He didn't describe it as that. He described it as though he was weighing the Earth. He was calculating the mass of the Earth, so that when you're attracted to the Earth through gravity, it's the product of the mass of the Earth, this big gravitational constant, divided by r squared, the radius of the Earth squared, which we normally know as acceleration due to gravity. And that quantity is essentially big G, and he measured it. And nobody could do a clever experiment. So he's a father of physics, experimental physics, some of the ideas of theoretical physics.